So today we discuss current electricity in circuit part, and here the important is a combination of resistor. Okay, so today discuss combination of resistor. That's very important. If you see your circuit board in your, suppose in your bedroom, you see that is switchboard, and there is some switch, and these switch are connected to, some switch are connected to lights, some are connected to AC, some are connected to fan, and there is some combination. Okay, mainly there are combination is a parallel combination, but somehow there is another combination, a series combination. And if you know that, okay, the combination of resistor, and you know the combination of capacitor and combination of inductor, and I think there is a very easy to solve any small problem in your home appliance or circuit problem. It is a connection problem. And if you know the combination, you also the fix the fuse problem. If you sometimes, if you see that there is a fuse must be cut, and now you change the fuse and there is a connection here, or you can draw a basic board or design your board, your, okay, these are called extension board. That is a help drawing that create and generate an extension board. Okay, that's very helpful for combination of resistor. If you know that, that's a basic concept here. Okay, so there are the two combination of resistor, either series combination and another is a parallel combination. So first we discuss the series combination. So the resistor is look like this. That is the resistor. And why is name came from resistor? And then a resist, this name suggests that it's a resist of charge flow. Resistor names came from resist charge flow. If charge flow be the resist, and we know that I equal to Q by T, if Q be the small, so current be the small. So actually resistance, the main purpose of resistance is the current value is very much lower. Okay, the block the current. Okay, the main purpose is the block the current. The current. Main purpose of the resistor. So here that two resistor, the resistance is R1 and the resistance is R2, and there is a series, so that's the current passes through that, is very important, are same. So in series, current resistance be same, but potential be different. But okay, so here the potential, that is V1, and here the potential is V2. So total potential is V, that is equal to V1 plus V2, and you know that V1 from Ohm's law, that is I R1 and that is I R2. Okay, that is V2. And total, that is a V T, and the VT, that is equal to I of RT total. So I of R1 plus I of R2. So I, the common, or you can say that is cancel I cancel. So you get RT, that is equal to R1 plus R2. That's the series combination of two or more, 2, 3, 4, 5. So just be added here. Okay, just simple algebraically added for combination of series resistor. Okay, now we discuss parallel combination. Okay, so parallel combination. So what is parallel combination? The parallel combination is that this is actually junction combination. Main important point is junction point. The basic parallel combination circuit of resistor, uh, it is it is called R1 resistance, that is a R2, and current passes through, that is I, and two branch here is I1 and other is I2. And in parallel, the important is that potential be the same but current be the different. Like series, the current passes to the resistor be the same but potential be the different. Here is a opposite or reciprocal. Current passes through the resistor be different, but current is different but potential be same. Be same. So calculate total current I, that is equal to these two current I1 plus I2, because these current divided two parts. That's the two part we added, these two part we get final current I. So that is equal to I1 from Ohm's law V by R1 and I2 V by R2, and total current I, that is V, potential be the same, that is R total. So cancel these three V's and we get RT equal to 1 by R1 plus 1 by R2. That's the basic circuit. Okay, that's a basic parallel combination of resistors. Okay, and you see that very carefully. That's the opposite of capacitor, series and parallel. Here you see, remember that in capacitor, series or parallel. So capacitor in parallel, see capacitor in parallel, capacitor here in series. So capacitor here in series. So 1 by capacity, total capacitance, that is 1 by C1 plus 1 by C2 and so on. But here in capacitor in parallel, so that is just be added C1 plus C2 and so on. So that difference is that only reciprocal concept. Here the series just must be added here, but capacitor there is the reciprocal concept. Parallel here is the reciprocal concept of resistor, but capacitor are just be added. This is a basic combination, series and parallel combination of that circuit. Okay. Now we discuss another important concept is called electrolytic cell. That's very important. That's the next page we discuss electrolytic cell or voltmeter. Okay. So here, what is electrolytic cell? And that electrolytic cell concept came from class 19 chemistry physics book. Okay, the basic concept. There is a beaker, non-conducting beaker. I recall this portion. Okay, non-conducting beaker, and there is a two electrode, and these two electrodes are graphite rod. Okay, and there is a solution. The solution here. This solution is electrolyte solution. Electrolyte solution. Okay. The concept is that now a cell, okay, a battery connected here. So when the current turns on, that is a positive terminal, that's a negative terminal. So now this terminal be the positive and that terminal be the negative terminal. Okay, and when these terminal get positive, this electrode now turn into the anode. this is turned into anode, and this electrode turn into cathode. Cathode. Okay. Now there is some exchange between ions. Okay. There is an exchange between some ion. So plus charge is loss of electron. So this anode lost electron and gain positive charge. Electron, and cathode gain electron and get a negative charge, and this electron is called ions. Okay, so these are called ions. Okay, when there is a two types of ion, is a cation, other is a anion. When cation is a positive and anion with a negative, and that electron goes not in air via that electrolyte solution. So actually this electron not goes from via air, is via electrolyte solution. Okay, now there is some notes if you're interested to write the notes here. So when the current turns on, what happens? When the current turns on, okay, when the current turns on, okay, so electron flow from anode to cathode. The electron flow from anode to cathode. Okay, and the cathode becomes negative electrode. Now cathode become negative electrode. So anode become positive because loss of electron gain positive. Okay, so anode leave the electron. Okay, and anode leave the electron to electrolyte solution. Cathode get the electron from electrolyte solution. That's very important. Anode lost electron and electron goes to electrolyte solution, and cathode get that electron from electrolyte solution. So if a cathode becomes negative electron, so anode is a loss of electron, means get positive ions here. The charge is called ion. So the charge is called ion. So cation, other charge ion is called anion. There are two types of ion. One is cation, other is anion. Okay, so cation with a positive, anion with a negative, and the cation goes to cathode and anion goes to anode. Okay, very important. Anion goes to anode and cation goes to cathode. So actually the cation migrate cathode during electrolysis. Okay, and the gain electron from cathode get reduced to become neutral atom. They're very important. And anion migrate anode during the electrolysis. Okay, and anion goes to anode during electrolysis solution and lost the electron to the anode and gets the oxidized to become the neutral atom. So here the difference is like that. So cation, suppose that is a positive ion, and here is an anion, that is a negative ion, a minus. First is concept is that migrate cathode during electrolysis. During electrolysis, the concept is, so anion migrate cathode. Okay, the migrate anode during electrolysis. Migrate anode during electrolysis. And the next important point, if I difference these two, gain electron from cathode. So gain electron from cathode. Okay, from cathode there's a gain electron. Okay, okay, cathode, and get reduced, become neutral atom, and get reduced, become neutral atom. Here the difference is the number 2, lost electron to the anode, lost electron to the anode, okay, and get oxidized to become a neutral atom, get oxidized to become neutral atom. So anion goes to anode and cation goes to cathode. So after that they become neutralized. Okay, that's very important. After that they become neutralized because there is a positive ion and get a negative ion from cation goes to cathode. So the cation goes to cathode, so they are neutralized, and anion minus, the anion goes to anode. That's why here we are neutralized, these two are okay. Now that's the cell is called electrolytic cell. Now before that there is a bunch of positive charge here and that is a bunch of negative charge here, and same circuit, the same cell. Now there is a little bit change. There is a change. A change is that now these battery, okay, and after connect that battery or electrolytic cell or battery here, these anode get huge positive and these cathode is huge minus here. Okay, now these connect a resistor, a load. Here is a connected load. So now the load concept here, like the current passes from higher potential to lower potential. So the potential here is a V plus, here the potential is a V minus. So potential difference between two electrode. Okay, so PD of two electrode, PD of two electrode, that is equal to plus of V plus minus of minus V minus. So finally you get V plus plus V minus. That's the potential difference between two electrons. Another good name is called electromotive force. Motive force is not actually a force. Okay, there is a EMF. EMF and short form is epsilon. Okay, that represents a volt. SI unit is volt. So electromotive force is not a force, that is EMF or a potential difference between two electrode. Okay, so that's the EMF. Clear? And here you see that when current passes through that circuit from plus to minus, and there's a R load and current in that direction via load, or current goes in that direction. So now here is the electron from here, current goes in that direction plus to minus via electrolyte solution, and via electrolyte solution, so there is an electron charge carrier move in that direction if current goes in that direction. Okay, so now be the calculation for here. There is a point, suppose that is A, that is point is B point, that point is C point, that point is D point. Okay, so potential difference between A and D. So PD, potential difference between A and D. Okay, so B, A and D. So here the protons move from A to B first. V A to B plus B to C plus C to D. The proton move from plus A to D. They move that path via electrolyte solution. If that moves via electrolyte solution, the current has a two direction current. One is via load, other is via electrolyte solution. And potential from A to B. So A to B are the same electrode, have same potential. So that's be the zero. And similarly C to D cathode same potential, so that's be the zero. That is B to C. So B to C, that is actually EMF, potential difference between two electrodes. That's the EMF. B to C, that is the EMF here. Okay, and the final potential, if there is a final, that is a cell or consider as a source, DC source, so there is a suppose there is a potential here. So V, the potential, there is a EMF, means B to C or potential difference between two electrodes, EMF, and there is a current direction. So one current direction, that other is the opposite direction. So that is equal to these currents. So that is a potential difference between these here, this line from electrodes to electrodes and by electrolyte solution. That is I times R, Ohm's law. By electrolyte, this comes from via electrolyte. Current passes by electrolyte, and that is V, that is equal to I, and that's V. So look like actually there now the circuit actually look like this. There is a source, positive terminal B plus, that's a B minus. There is a load RL. So current goes or passes through that direction, plus to minus direction. So one current passes in that direction, that's this direction, and other currents in that direction, plus to minus via electrolyte solution. That is IR. Okay, so you get I plus R minus small r, that is EMF. I equal to EMF by plus R. That's the final expression. So maximum current, when max current flow, so max can be the short circuit. CKT stands for circuit. So load resistance will be 0. So that is I equal to EMF by small r. Okay, that's the max current. Clear the concept. What is the max current? How to get the max current here? And here the difference is that from electrolyte cell, here we discuss how to get charge stored that to electrode and via electrolyte solution. How to store? When a current passes through that, these two are, suppose there's two electrodes, get some energy store here, some charge store here, and after that, when you move that battery or source supply, remove that, so some current will store here. Now there's some charge will store here. Now this charge will loss, a current passes through that, this is load. And here we the current store, and here is a loss, charge loss by loss. When current passes through that, these two are becoming neutralized. Two tends to neutralize. These two, anode and cathode, it tends to neutralize these terms. That's that tends to neutralize. Okay, yeah, neutralize. And clear the concept. How do we actually that's part be our syllabus. that is the recap. Okay, class 9 and 10 syllabus, and that is our final class 12 portion. Clear? How to get a current, and that is called a voltaic cell. Okay, and here the another concept. These are small r, and another is a capital R. And you see the diagram. The small r is the internal resistance of the cell, and the small r is the internal resistance of the cell. Here that it has a current flow, so there is a very small amount of resistance, and that small r is less than much less than the capital R. So capital R with the load resistance. That is the load resistance. Okay. So here clear the concept, that is a smaller represent that internal resistance, and that resistance depend on electrolyte solution. Okay, and if a gap between these two electrode or many other factors here. Okay, clear. Next concept we discuss cell in series and parallel. These are the cell. When I remove that, these, if I cut that portion, remove the load, and these two are called as cell. So that is a cell means a source of energy. Suppose there is a source of current, actually there is a plus and that is a minus. Okay, plus terminal, that is a minus terminal, a voltage source here. So cell in series and parallel. Next concept is cell in series and parallel, but here we discuss series only. So this long represent the positive terminal, small negative terminal, positive terminal, and negative terminal. Okay, so potential, suppose that is a B and C point. So potential here, that is VAB from these, and B to C, that is B to C. Okay, and the represent is EMF 1, that is EMF 2, that is internal resistance 1, that is internal resistance R1, and that is R2. Okay, so VAB, see that VAB, potential difference between A and B point, that is equal to VA minus VB, and VBC, that is VB minus VC. Okay, and VAB, and you see that very carefully, there is a EMF 1 in that direction, and internal resistance current in that direction minus, okay, that is the current I R1. Similar VBC in that direction current, and from very small internal resistance current by internal resistance current is in that direction, that is epsilon 2 minus IR2. Both current be the same because they are in series connection. So total potential VAC, these VAC, that is equal to VA minus VC, and just we added these two, that is equal to VAB plus VBC. Just because added these two potential, we get a final potential because they are the superposition theorem satisfied. So just we added algebraic. So VAC and get VAB, and VAB you get, that is EMF 1 minus IR1, and that is BC EMF 2 minus IR2. So finally we get EMF 1 plus EMF 2 minus, take commons, minus I. So R1 plus R2. Suppose we say that is a EMF equivalent minus I R equivalent. That is internal resistance equivalent. That is VAC, the total potential. Okay, into the I. Clear? And if a more potential cell is connected here, because just we added here just okay, so the EMF equivalent is like that, EMF1 plus EMF2. If I say connect another 2 3 4 cell, it just be added here. So R equivalent resistance, very small resistance or internal resistance, that is here we just be added R1 plus R2 plus R3, just be added here. Okay, there's a cell in series. The final conclusion is that they just must be added. Okay, the EMF minus there is some very small amount of potential cancel, very small, because R equivalent is very small compared to the load resistance. Now another concept we discussed, cell in series. So other is a cell in parallel. Very easy concept. Cell in parallel. So the basic circuit diagram of parallel, there is a junction point because there is a 3 branch here, one cell, okay. So suppose current flow in that direction. Suppose there is a I1, I2, that is I, that is the EMF1, that's the EMF2, that is R1 internal resistance, R2. So in parallel, potential be the same. Okay, just be calculation here for that. That is 2 node here. Suppose that is a node A, and you say that's a node B. Okay, node A and node B here. So here the calculation VAB from upper part. Okay, VAB from upper part, you see that that is equal to for upper UP upper part, this part. So that is equal to EMF1 minus I1 R1. So VAB lower part, that is EMF2, this lower part, I2 R2. Okay, now these two equation number give that 1 and 2. So here the potential be the same, okay, but current be the different here. In parallel, current be the different here. So total current here I, that is equal to I1 plus I2. You see the diagram here, I1 enter, I2 obviously enter, now passes through that line. So here simply see the diagram carefully, that is these two can be added to get a final current I. So I1, and here you get I1 value. So V AB and V upper and lower be the same. Okay, these two are equal. So V minus epsilon 1 minus I1 R1 and get epsilon 1 minus V by R1 equal to I1. Similarly, that I2 to epsilon 2 minus V by R2, that is equal to I2. Now these are the equation number. If I not give here equation number, that is a 3, that is 4, and these 3 and 4 put here, and we get final expression here, 3 epsilon 1 minus V by R1 plus epsilon 2, that is actually EMF, okay, minus V by R2, okay, that's the I. So final expression, that is actually calculation here, okay, epsilon 1 by R1 minus V by R1 plus epsilon 2 by R2 minus V by R2. So here you see that epsilon 1 by R1, epsilon 2 by R2 minus V common, 1 by R1 plus 1 by R2. So if I erase LCM this R1 R2, you get epsilon 1 R2 plus epsilon 2 R1 minus V R1 plus R2 by R1 R2, that's equal to I. And just basic solution, go to the next page, and that is I equal to so now both side, okay, here that both side multiplied by R1 R2 by R1 plus R2, R1 R2 by R1 plus R2, and you get the V, final V value, that is EMF 1 R2, EMF 2 R1 by R1 R2. So R1 R2 by R1 plus R2, that is the final V. So cancel these two, okay, and that's V equal to epsilon 1 R2 plus epsilon 2 R1 by R1 plus R2 minus I R1 R2 by R1 plus R2. That's the final expression of potential. Okay, that's the final expression of potential. Here these represent called EMF equivalent. This minus I R equivalent. Okay, that is the equivalent. And you see that diagram, or see that equation here, or diagram obviously, that's the for parallel connection in cell and series connection in the cell, we both be equal. Okay, just but difference is that the equivalent, EMF equivalent and R equivalent be the difference here. So here the EMF equivalent is, so EMF equivalent is look like, so that is EMF 1 R2 plus EMF 2 R1 by R1 plus R2, and R equivalent, that is equal to R1 plus R2 by plus, so R1 into R2. So that's the basic concept here. Cell equivalent or cell equivalent, cell series in cell parallel. That's the basic concept. That is a cell parallel equation, and that is a cell series equation. Okay, clear the concept. So today wrap up the class here, and if you have any doubt in that portion, always ask in comment section. I will try to give the answer. Next class we discuss very important concept, very important in board exam, JEE NEET exam, Kirchhoff's law. Okay, so today in the class, thank you.